Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we talked about various components of time series, statistical controls, various control charts for inspecting the statistical control in process or not, P chart, X bar chart, NP chart, C chart, etc. were discussed. After studying about time series and control charts, in continuation we are going to study about acceptance sampling plans. That is, in this session we are going to discuss about various acceptance sampling inspection plans. First of all, what is meant by sampling? Why do we do sampling? What is a sample? And why do we do a sampling inspection? And what are the plans for accepting such kind of sampling inspection plans? What are the guidelines? What are the objective? Everything will be discussed in this session. So, first of all we start with what is exactly acceptance sampling inspection plan. In many a manufacturing process, the producer, in order to ensure or in order to satisfy the customer, the manufactured goods are ensured according to the specifications of the customer. So, he gets his lot checked at strategic stages. That is, at particular stage the item is checked and the process was run, the process was made to run, and again item will be checked for quality control. It is the job of the producer to satisfy the customer. What is the job of the customer? The customer is anxious enough to satisfy himself about the quality of goods he or she accepts. An ideal way of doing this, that is doing this in the sense producer checking the item and customer getting satisfied, is to inspect each and every item presented for acceptance. That is to resort to 100% inspection. Is it possible for 100% inspection and 100% satisfaction? That is the question mark. 100% inspection in the sense it should be taken into recourse to the following conditions. The occurrence of a defect may cause loss of life or a serious casualty to personnel. So, very much care should be taken when you are doing the inspection and the same time when you are doing the manufacturing process. So, the defect may cause a serious malfunction of the equipment also, causing the trouble to the people as well as to the customers. So, we may also wish to examine all the items of the products under the following conditions. When the lot size, that is number of samples, is small. Lot size is different from sample size. Sample size is number of items in a particular sample and the lot size is the total number of samples taken for consideration. And another condition is when the incoming quality is poor or unknown. If testing is destructive, as for instance in the case of crackers, shells, bulbs, etc., it is absolutely nonsensical to talk about 100% inspection. Even in those cases when 100% inspection is possible, it may not be desirable because it is very costly and it is fatigue, impossibility of proper check and variations in efficiencies of inspection in time, person, place. However careful one may be, the inspected lot is likely to contain a small percentage of defective. So, from practical and economical considerations, sampling procedures are adopted. So, from practical and economic consideration, sampling procedures are adopted. That is, a lot is accepted or rejected on the basis of samples drawn at random from the lot. So, it has been found that if a scientifically designed sampling inspection plan is used, it provides adequate protection to producer as well as consumer very economically. So, what is the basic objective of inspection? The basic objective of inspection is to control the quality of the product by critical examination at strategic points. Sampling inspection, besides keeping down the cost of production, also ensures the quality of a lot accepted is according to the specifications of the customer. What are the guidelines to be followed when you are inspecting? The guidelines of a sampling procedure are: it should give a definite assurance against passing any unsatisfactory lot, and the inspection expenses should be as low as possible, subject to the degree of protection. That is very important, degree of protection afforded by the point A above. So, acceptance sampling plan refers to the use of sampling inspection by a purchaser to decide whether to accept or reject a lot of a given product. When you want to say in terms of statistical quality control terminology, it is said to be called as product control. We have already studied there are two types of controls, that is, one is product control, another one is process control. A process control we have seen with control charts like X bar chart, R chart, NP chart, P chart and C chart. Now, this we are going to study is a product control, and this can be done with the acceptance sampling inspection plans. In case of acceptance sampling by attributes, the decision for accepting or rejecting a given lot is taken on the basis whether the sample items possesses a particular attribute or not. It is like the presence of the attribute or the absence of the attribute. When the presence of the attribute, it means the product is accepted, and in the case of absence of that particular attribute, the product is rejected. In other words, acceptance sampling by attributes is an attribute based inspection that merely grades the product as defective as or non-defective. If the product is found defective, it is rejected, and if it is found non-defective, it is accepted. Now, what is the necessity of acceptance sampling? The necessity of acceptance sampling arises from the fact that when a lot of product is transferred from one firm to another, or from one division of a firm to its another division, or like from a seller to the buyer, the recipient of the lot wants to be reasonably sure that the lot meets the standards already agreed upon with regard to the quality of the product. In other words, acceptance sampling prescribes a procedure that, if applied to a series of lots, yields quality assurance by involving a decision to accept or reject a lot on the basis of the random samples drawn from it. Now, we will step into discuss about various concepts regarding acceptance sampling inspection plan. First one is AQL, that is acceptable quality level. This is the quality level of a good lot. It is like it is the percent defective that can be considered satisfactory as a process average and represents a level of quality which the producer wants accepted with a high probability of acceptance quality level. it is called as AQL. A lot with a relatively small fraction defective, that is sufficiently good quality, say P1, that we do not wish to reject, although it is defective, the defective is so small that the product can be accepted. So, we do not want to reject more often than a sample proportion of times, and sometimes referred as a good lot. That is, when the probability of rejecting a lot of quality P1 is equal to 0.05, it means accepting the lot is 0.95. That is, we are leaving only 5% for the risk level, that is, we are not sure about what will happen in the 5%. We can say whatever the interpretation comes, as we are 95% confident about the acceptance of the good lot. So, that is like a percentage of acceptance is prescribed. So, probability of accepting a lot of quality P1. So, the quality is called P1, and we are accepting it when it is probability is 95%. This P1 is called acceptable quality level, and a lot of this quality is considered as satisfactory by the consumer. Next terminology is LTPD, that is lot tolerance proportion of percentage defective. Now, instead of discussing about only good lots, now we are discussing about rejecting parts where the number of where the defective is considered to be very small, and the defective is very small, the lot is considered to be good and it is accepted by the consumer. So, next one is lot tolerance. Lot tolerance, we can tolerate that kind of percentage defective, that is called lot tolerance proportion of percentage defective, LTPD. Now, the lot tolerance proportion defective, usually denoted by PT, is the lot quality which is considered to be bad by the consumer. The consumer is not willing to accept lots having proportion defective PT or greater. Okay. 100 PT is called a lot tolerance percentage defective. In other words, this is the quality level which the consumer regards as rejectable and is usually abbreviated as a RQL, rejecting quality level. We talked about acceptance quality level, that is P1, and this is rejecting quality level RQL. A lot of quality PT stands to be accepted some arbitrary or some fraction of time, usually 10%. Next terminology is process average fraction defective. This process average fraction defective is P bar. This P bar represents the quality turned out by the manufacturing process over a long period of time. For example, in industry, the quality of any process tends to settle down to some level which may be expected to be more or less the same day for a particular machine. If this level could be maintained and if the process is working free from assignable causes of variation, the inspection could often be dispensed with. Okay. But in practice, as a result of failure of machine and men, the quality for the product may suddenly deteriorate. So, therefore, the process average of any manufactured product is obtained by finding the percentage of defectives in the product over a fairly long time. Consumers risk. There are two types of risk. One is consumers risk, another one is producers risk. Any sampling scheme would involve certain risk on the part of the consumer, in the sense that he has to accept certain percentage of undesirably bad lots. So, when the consumer has accepted the bad lot, it is actually a kind of error, and when he accepts an undesirably bad lots, that is lots of quality PT. PT is actually rejecting quality level, and when he accepts that kind of lots, then that risk goes back to the consumer. Therefore, it is called as consumer's risk, and we have already discussed this in the previous sessions, and this is called type 2 error. So, more precisely, the probability of accepting a lot with a fraction defective PT is termed as consumer's risk, and it is denoted as PC. Consumer's risk PC is equal to probability of accepting a lot of quality PT is equal to beta, consumer's risk. Now, the producer also has to face the situation that some good lots will be rejected. Good lots are rejected in the sense it is also an error, because a good lot has to be accepted. When good lot is rejected, it is an error. That kind of error is called a type 1 error, and since it goes back to the, when it is rejected, it goes back to the producer, so it becomes the producer's risk. He might demand adequate protection against such contingencies happening too frequently, just as the consumer can claim reasonable protection against accepting too many bad lots. So, in that case, the probability of rejecting a lot with 100 p bar as the process average percentage defective is called the producer's risk. So, P of P is usually denoted by alpha. Therefore, producer's risk is P of P is equal to probability of rejecting a lot of quality P bar, and it is equal to alpha. Alpha is called producer's risk and beta is called consumer's risk. Next, we talked about acceptable quality level and rejecting quality level, and we talked about acceptance sampling plans. Next, rectifying inspection plan. When somebody accepts and if it happens to be bad, then it is rejected and it goes back to the producer. So, the producer has to rectify what is the problem in that particular lot, and we have to rectify. So, that kind of rectifying in also has to be done by the producer. Therefore, he has to design a rectifying inspection plan for that. In the following sections, we shall discuss lot by lot sampling plans in which a specified quality objective is obtained through corrective inspection of rejected lots. Like when we drawing the control charts, when we see when there are the sample points lying outside the UCL or LCL lines, we compute the revised UCL and LCL by removing that particular sample items. That kind of rectification is done with the lot. So, the inspection of the rejected lots and replacing the defective pieces found in the rejected lots by the good ones eliminates the number of defectives in the lot to a great extent, and thereby improving the lot quality. These plans are called rectifying inspection plans and were first introduced by Dodge and Romig, and therefore, there is a specific table called Dodge and Romig table of the telephone laboratories before World War II. Now, these plans enable the manufacturer to have an idea about the average quality of the product that is likely to result at a given stage of manufacturer through the combination of production, sampling inspection and rectification of rejected lots. Most of the rectifying inspection plans for lot by lot sampling call for 100% inspection of the rejected lots and replacing the defective pieces found by good ones. The two important points related to rectifying inspection plans are the average quality of the product after sampling and 100% inspection of rejected lots called average outgoing quality AOQ, and the average amount of inspection required for the rectifying inspection plan called average total inspection ATI. Now, these kind of abbreviations is very important. We talked about acceptance sampling plan. AOQL we talked, that is average outgoing quality level, and we talked about AQL, acceptance quality level, and LTPD we talked about, that is lot tolerance proportion defective, and then we talked about AOQ, that is average outgoing quality, and then ATI stands for average total inspection. Now, let us discuss in detail about AOQL. AOQL is average outgoing quality limit. Sometimes the consumer is guaranteed a certain quality level after inspection, regardless of what quality level is being maintained by the producer. That is, the producer may claim 95% confident about the functioning of the particular product, and if it does not happen, you can just return back the item. Like this kind of agreements or this kind of guarantees can be given by the producer, whatever the quality level they are maintaining, and the customer is guaranteed such kind of quality levels. The producer's fraction defective, that is lot quality before inspection, BP. This is called as incoming quality. The fraction defective of the lot after inspection is known as outgoing quality of the lot. So, the expected fraction defective remaining in the lot after the application of the sampling inspection plan is known as average outgoing quality, that is AOQ. It is represented as P. Obviously, it is a function of the incoming quality P. So, we talked about incoming quality and outgoing quality. The most important remark here is for rectifying inspection, single sampling plan calling for 100% inspection of the rejected lots, the AOQ values are given by the formula P bar is equal to AOQ, is very basic important formula, P into capital N minus small n into P A divided by capital N, where capital N is the lot size means number of samples, and N is the sample size, and PA is the probability of acceptance of the lot. The formula assumes that all defectives found are repaired and replaced by good pieces. Now, since we look for defective pieces in the uninspected portion of accepted lots involving n minus n items, and since P is the probability of finding a defective, there will be on the average P into capital N minus n defective items. Since PA is the probability of acceptance of the lot, the sampling plan will on the average turn out lots that contain P into PA n minus n defective items. Consequently, on dividing by n, we get AOQ as a fraction defective given by the formula P bar is equal to AOQ is equal to P into n minus n into PA divided by capital N. This is how the proportion defective or the fraction defective is calculated. If n is small compared with capital N, then a good approximation of the outgoing quality is given by P is equal to, because when n is small, then capital N minus n is very small, therefore, capital N minus n by n. That actually the formula is P into PA, capital N minus small n by capital N is written as P into PA 1 minus small n by capital N. When this n is small compared with capital N, this can be assumed to be tending to 0. So, we have only P into PA. If the defective pieces found are not repaired or replaced, then the formula must be modified to AOQ is equal to P into n minus n into PA divided by capital N minus NP minus P into 1 minus PA into n minus n. So many things has to be subtracted from the lot. It has to be removed, okay, and the formula becomes small p n minus n PA by what all can be cancelled. We see that capital N minus P into n PA plus capital N into 1 minus PA. In general, if P is the incoming quality and a rectifying inspection plan calling for 100% inspection of the rejected lots is used, then AOQ of the lot will be given by AOQ, acceptance outgoing quality, is given by P of A plus 0 into 1 minus P of A P, probability of acceptance, okay, and this is nothing but P into P of A of P. Because P of A of P is the probability of accepting the lot of quality P, and when the lot is accepted on the basis of the inspection plan, the outgoing quality of the lot will be approximately same as incoming lot quality P dash, and 1 minus P of P is the probability of rejection. P A of P is probability of acceptance, means 1 minus P A of P is the probability of rejection of the lot, and when the lot is rejected after sampling inspection and is subjected to 100% screening and rectification, then AOQ becomes 0. And for a given sampling plan, the values of AOQ can be plotted for different values of P to obtain the AOQ as given in the 1 minute. This is AOQ, and this is goes like this, and this particular level is called AOQL, that is average outgoing quality limit. In this session, we discussed about two types of inspection plans. One is acceptance sampling inspection plans and rectifying inspection plans. Various terminologies related to acceptance sampling inspection plans like AOQL, LTPD was discussed, and the terminologies related with rectifying inspection plans like AOQ and ATI was discussed. Based on the discussion in this session, the following question may be posed. What is meant by sampling inspection? Explain the terminologies AOQL, AQL, LTPD and ATI. Thank you.